now see the second observation. In that the DC input voltage V. Okay, here use the DC input voltage apply to the power supply, and this power supply is connected in our circuit diagram. Here one number is the ground and input is applied to the 5 number pin of our IC 555. 5 number pin is the control voltage. Okay, and output is measured in a, here see the CRO. This CRO pin cable is connected in a, negative is connected in a ground in a pin number 1, and output is observed. We have connected here 3 number pin of IC. Okay, and power supply is on our circuit. Okay, here see in our power supply apply the 1.5 volt. Okay, in a DC input voltage. Then observe the output waveform. Here output waveform is a square waveform. Okay, then this output waveform's pulse width is measured. See here the pulse width of output waveform is, here see in our CRO this line is a 1 2 3 small lines, that means the 0.6. Okay, and 0.6 multiply the time per division knob is a 0.2 millisecond. Okay, see the here note down in our observation table DC input voltage V is the apply the power supply voltage is 1.5 volt, output pulse width is a 0.C into 0.2 millisecond. Okay, then second reading here change the input voltage 1.5 to 2. ते आपण काय करणार आहे 2 करणार आहे. Then observe the output waveform. See the here observe the output waveform in our CRO and measure the pulse width 0.8. Okay, see the 1 2 3 4 small lines, 0.8 multiply time per division is a 0.2 millisecond, and note down in our observation table. See in this way. Okay, second, change the input voltage 2 to 2.5. Okay, then observe the waveforms on a CRO pulse width. Okay, multiply the time per division, and here right now our power observation table. Okay, in this way the voltage is vary 1.5 to 2.5 3. Okay, see here change the voltage in a 3. Okay, then observe the output voltage. Okay, observe the output waveforms pulse width in our CRO. Okay, then multiply the knob in a time per division. In this way the different apply the DC input voltage and observe the output pulse width in a millisecond. Okay, in this way the different readings are note down in our observation table. See in this way. Okay, then this table used, here we have draw the graph. Okay, in this table using here draw the graph in output pulse width versus input voltage. In x axis here gives to the input voltage, and y axis here gives to the output pulse width. Okay, see in our table input voltage increases. Okay, so output pulse width is again increases. See the here 1.5 volt 0.12 millisecond in pulse width. In this way 2 volt, then 1.16. Okay, 2.5 0.20. In this way this output pulse width again increases. Okay, so here graph काय येणार आहे, ग्राफ स्ट्रेट येणार आहे. म्हणजे आपण जसं इनपुट व्होल्टेज इंक्रीज करेल तसं आउटपुटची पल्स विड्थ ही काय होते याच्यामध्ये इंक्रीज होते. ओके, देन रिझल्ट, सी द रिझल्ट. thus studied as IC 555 ॲज अ पल्स विड्थ मॉड्युलेशन. आपण काय केलं याच्यामध्ये तर IC 555 टायमर, ओके, This IC555 is used in a circuit, a variety of timers, delays, pulse generations and oscillator. These different applications used in a IC555. Okay, here used pulse width modulation by using the IC555. Okay, applying the AC input waveform in a voltage and observe the output pulse widths. Then another apply the DC input voltage, hold in measure the output of a pulse width in a millisecond. Okay, in this way this our experiments is successfully studied, okay, in our laboratory by using the different electronic components, okay, then electronic devices. Okay, I think got it all of you, this experiment IC555 as a pulse width modulation. Okay, stop here. Thank you all of you.